Today we're going to be solving one common problem, which is called the two-sum problem. Given an array of integers nums and an integer target, return indices of the two numbers given that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So you're going to return the answer in any order. And basically we have this array, we have a target 9, and we say that the 0 and 1 index make up 9. And that's correct because the 0th and 1 index has elements 9, 2 plus 7, which equal to 9. Now over here we have target 6, and we say the 1 and 2nd index make up 6. Over here we have target 6, and we say 0 and 1. So, example 3, like that. And these are some of the constraints. Only one valid answer exists. So let's go ahead and write the code here. So what we have here is a class solution, and we have a public vector int return type, and we have two-sum, and then we have nums, which are in a vector int, and then we have a target. We could create a vector here for the return type, and this is going to be called the results. So I'll call the vector int, and we'll say results, and this could be an empty vector so far. We don't have to populate anything into it until we get our indices, right? Like this 0 and 1 when we want it at the end. So what we could do is we could first of all create what can we create? Well, we have a target, and we want to put it inside of some kind of set, because I want to make sure, like, if the we have two things to consider. One, we have the number, and second, we have its index, right? So we might need to have like a map. So for that we could use an unordered map. Okay, so we could use over here, we'll say unordered underscore map, and then we have int, and then we have number frequency. Okay, so we're using a map, and over here we'll have the hash include, and we have unordered underscore map. Alright, and then in here we have the int number frequency, and then over here we have the results. Now over here we could just have, like, for each number, like, what is the count, right? Like this number and then the count. I could put that in a for loop. Like I could go traverse the entire number frequency. So I could say nums.size function, and then we could have the I++, and we could traverse and see all this results. So first of all, we have this numbers, and then we have the frequency for it. If I look over here properly, we have a vector int results, and we have int I is equal to 0, I is less than nums.size, and we have plus I++. But what two numbers could actually make up that? First of all, we check the complement in each time. So right now, how can I make up the complement? Well, what you could do is you basically have the target and the number index. So you could say int complement, okay, is equal to, first you have the target and the number. So numbers sub I, and then we have minus the target. Suppose I have a number, let's suppose 3, and then I minus it with target, which is 6. Well, that's not good. We might have to have the target here, because target is always going to be bigger, minus the numbers sub I. That will be our complement, and we have to check if the complement exists in our hash map or not, right? If, then we have number frequency dot find complement, and we say equal to number frequency dot end. Now, what it means here is that if the complement does not exist, right, the number frequency, we could, what I said is that if the complement does not exist in this hash map, what we could do is we could put it inside here using number frequency in the subscript. You could put in the complement, so key as the complement, all right, and then the value to it would be the index, meaning this. I hope you understood this, because that's going to be the index of the thing. And if suppose it already exists in there, right? So if it already exists inside the hash map, what you could do is you could return it. So what I'm thinking here is, right now, if the complement suppose exists in here, right? You could actually return it, and then wait a minute. So just say if the complement does not exist in here, we add the complement, all right? And if the complement does exist in there, then we have its index as well, right? Oh, I understand now. So we could basically return it. So what we say is else, and then we have results dot push underscore back. What we have to return is, first of all, the complement itself, but the complement actually just has the number. We want its index, right? So we want the number frequency complement. Number frequency complement. So this is going to give the index of the complement. And we also want the index I, which is going to be the other index that we're traversing upon. Alright? These both go in the results. And then we actually could return results. Else we just keep going, and we could actually return, you know, an empty result if it never passes this else case. So 4, and then we have this. Okay. So now let's just run it and see what happens. Okay, we got a wrong answer. We got 2, 7, 11, 15. Target is 9. And output is this. Well, expected was that. Okay, so kind of made a mistake here because it's returning an empty list. So basically, you're not dry running the problem properly. We have num frequency.find complement, and if it doesn't exist in there, we would prefer to have the, you know, the, what is it called, numbers, which is this one. sub I, which could give the value of the number. Numbers sub I, which could give the value of the number. Basically, we need to dry run this. It could give you a frequency, and inside it we have the value, which is nums sub I, and then we have I. Num frequency, nums sub I, then we have I. Num frequency, num sub I, and then we have the value. I don't understand properly, but number frequency dot find complement is equal to num frequency dot end. This means that we have the map inside. We have, so if the it's better to comment if the number does not exist, or if the complement number does not exist in the map. What you do is if num frequency dot find complement, we add the number. So we have num frequency nums sub I, which is the number, got it, and then the value for that would be I. Else, if it already exists, we'll just we have the num frequency complement, so this is how it worked basically. Let me just revise it one last time. So we had a vector to sum, and we had nums, and we have a target. Created an unordered map. We had a results vector, and then over here we created this num size traversal. We got the target, and then we subtracted with the nums I, got the complement. Suppose if we dry run it, I had an array which has, suppose, like, there's so many examples, but let's take this one, which is 1 second, 2, 7, 11, 15. So we have 2, 7, 11, and then we have 15. So if we have this vector and we want to have the target as, suppose, 9, okay, we want the target as 9. So what we could do is we could go in the target minus num. So whatever the target is, suppose we have target as 9, so we have 9 9 minus, and then we have num sub I. So target whatever it is minus Bro, target is basically anything. This is a common feeling, to be honest. You always will get stuck, but you have to learn in every point. Like, okay, I could still do it. I could still do it like that. That's basically programming. So we have a 9, all right, which is the um, target, and then we have -2. Whatever that result is, 8, 7. So it's basically 7. The complement is 7. That should exist in it, right? That's the 7 complement. So if that over here we have, if the complement does not exist, right? We basically go in the number frequency hash map, get the num sub I, whatever that number is, right? And put its index inside of the hash map. If not, if that exists, we return the number frequency complement because it already exists in there, and we return its index because that's basically both of these indexes, the complements and the um, complement index, as well as uh, the number index, which is um, current number index. So basically we both get these and return them. That's basically a pretty beautiful solution. And yeah, it worked and it's a success. Awesome. We can now safely go to our practice cheat sheet, and over here we can mark it that we completed it. We have marked 3 questions so far and a really good progress. So let's just check this out, and we will go to our arrays and hashing part for easy is completed. Now we will move on to 2 pointers soon. Stay tuned.